All right, as advertised in my last video, we will be talking about the binomial series this time. So what is a binomial series? So let's consider f of x as 1 plus x to the r. Its Maclaurin series gives us what's known as the binomial series. So if r is a real number, the Taylor series centered at 0 we can find by doing what we've been doing, and you get 1 plus r times x plus r times r minus 1 over 2 factorial x squared plus etc. etc. And the Taylor series converges at the very least for the absolute value of x less than 1, and possibly at the endpoints depending on r. Of course, if r is a positive integer, then we know that this is going to converge for all values of r, but all values of x, not all values of r. The binomial coefficients, you probably remember this from, I don't know, middle school, elementary school. Okay, I know that may have been a while ago, but anywho. It's basically like r choose n, right? R factorial over n factorial times p minus n factorial, which is, so this is equal to this. And sort of that's the formula we're going to use even if r is a real number and not an integer. So maybe you don't believe me. So we can start by f of x. F of 0 is 1. F prime of x, r times 1 plus x to the r minus 1. So f prime of 0 is r. We take the second derivative, we're going to get r times r minus 1. The third derivative, right, we get r times r minus 1 times r minus 2, and so on. And in general, we get that this is the formula for the nth derivative. And so where the series converges, right, we just plug in the derivatives, and then everything's always divided by, n factorial. And so that's why we get that formula. Now we know again that if r is a positive integer, that the nth derivative for n bigger than r is going to be 0, so the series is finite, and again, it always will converge. So as a quickie example, and I know this is something that a middle schooler or a high school student actually will be able to do. We have 1 plus x to the 6th is going to be 1 plus, well, let me just write the binomial expansion, right? We have 6 choose 0 plus 6 choose 1 times x plus 6 choose 2 x squared plus 6 choose 3 x cubed, 6 choose 4 x to the 4th plus 6 choose 5 x to the 5th plus 6 choose 6 x to the 6th. Which is pretty straightforward. That's going to give me a 1 plus 6 over 1 factorial times x plus 6 times 5 over 2 factorial x squared plus 6 times 5 times 4 over 3 factorial x cubed plus 6 times 5 times 4 times 3 over 4 factorial x to the 4th plus 6 times 5 times 4 times 3 times 2 over 5 factorial x to the 5th plus, if you think about it, 6 factorial over 6 factorial x to the 6th. So I get 1 plus 6x plus 6 times 5 divided by 2 is 15 x squared plus 20 x cubed plus 15 x to the 4th plus 6 x to the 5th plus x to the 6th. And sort of that's the idea. So now let's see how this plays out when x is not a positive integer. So I have a couple of examples, and that'll do it. So first of all, we want to write this as, 1 plus x to the 1/4 power. So that's our power. All right, so r is equal to 1/4. So what is our binomial series going to tell us? In general, for these guys, we are not going to have a nice closed form solution. We'll just, write a few terms. So I don't know why I'm writing the ... because I'm getting ahead of myself. I'm ready to write the few terms. So I'm going to have 1/4 choose 0, 1/4 choose 1, 1/4 choose 2, 1/4 choose 3, plus, and I'm just going to stop there. This can keep going forever. All right, so this is going to be 1/4. No, that's not true. I lied a lot. This is always 1. Okay, so we're going to get plus 1/4 over 2 factorial times x plus 1/4 times 1/4 minus 1 over 3 factorial x squared plus 1/4 times 1/4 minus 1 times 1/4 minus 2 over 4. That's totally wrong. Sorry, over 1 factorial over 2 factorial. I got to get it together, huh? Over 3 factorial plus ... etc. So I get 1 plus 1/4 x. This is going to give me a minus, so let's see, minus 3 over 32 x squared plus 7 over 128 x cubed plus etc. And so why there's a whole page there, I'll never know. So kind of side work, I guess. Okay, so if you have any questions on this, just like always, don't forget to write them down and ask them during class. All right, what about this one? This one's very interesting. Okay, so first of all, we see that we can write this as 4 plus x squared to the 1/4. The problem on this one is, well, the problem occurs right here, right? Because this needs to be a 1. Okay, so how are we going to do this? Well, what we're going to do is we're going to write this with a factoring of 4 out. So we can factor a 4 out inside there, and then that's going to give us 4th root of 4 times 1 plus x squared over 4 to the 1/4. Now from the previous example, right, 1 plus x to the 1/4, we have 1 plus 1/4 x minus 3 over 32 x squared plus 7 over 128 x cubed plus ... So that tells me, first of all, that 1 plus x squared to the 1/4 is going to be 1 plus 1/4 times x squared minus 3 over 32 times x squared squared plus 7 over 128 times x squared cubed plus ... which is 1 plus 1/4 x squared minus 3 over 32 x to the 4th plus 7 over 128 x to the 5th. That's not the 5th. 3 times 2 is still 6, right? X to the 6th plus ... And so finally, the 4th root of 4 plus x squared is going to be the fourth root of 4 times this. So times 1 plus 1/4 x squared minus 3 over 32x to the 4th plus 7 over 128x to the 6th plus dot, dot, dot. And so that's all I have actually for this one. So next time we will do more fun and exciting things. What are we going to do next? Well, next time we are going to talk about working with Taylor series. So until next time, have a good day. Stay